Today I'm going to show you the method that I use to sharpen one of these twist drills. Now there's many methods to do this, but the one that I use I find quick and easy. You don't need any fancy jigs. You just need your eye, your hands, and one of these simple grindstones. And I can sharpen or touch up a drill bit in a few seconds. And you don't need a lot of skill to do this. You can develop the skills that you need within a few minutes, really. And these twist drills have been around a long time, but they are beautifully engineered. They were invented in about the 1860s by a chap called Stephen Morse. And we haven't improved much upon it in the last 160 years, so it shows what a good design it is. Now these are basically designed for drilling in metal, but they work equally well in other materials like wood and plastic, etc. It's very important to understand the basic design of these drills and to try and repeat that design with your sharpening. If you don't, your drill's not going to perform well. And if you don't have a good understanding of how a twist drill works, you'll never get consistent results. It'll be random. You'll have some good ones, you'll have some bad ones. So it's worthwhile spending a minute just understanding the design and what you're trying to achieve with your sharpening. Obviously these twist drills rotate in a clockwise direction like that. They consist of a shaft of the drill. There's two flutes, one on this side and one on that side there. And then the business end looks like this. There's a center point there, and then there's two working faces, or lands they call them, one going that way, one going that way. Then there's two cutting edges marked in white here, and two trailing edges marked in blue. The cutting edges you'll notice are straight, and the trailing edges you'll notice are curved like that. So that's how you identify them. And then in the middle here is a little ridge, and that ridge is called the chisel edge. It's not very efficient at cutting, and the wider the diameter of your drill, the longer that chisel edge is, and the harder it is to penetrate a hard material like mild steel or something like that. So with a very wide drill, you very often need a pilot hole, and you will drill a pilot hole that's wider than the length of that chisel edge. And what that does is allow the cutting edge to make contact with the material, and it gets rid of that problem of the chisel edge being quite blunt and not very efficient at cutting. Now it's important to get the correct angles on all these features on the business end. If you don't get that right, then your drill's going to not cut at all or behave badly when you're drilling. Now the first angle we're concerned with is called the point angle. There's the point, and then the two working faces come off at an angle of about 60 degrees off the horizontal. So if you drew a horizontal line like that, that angle, it makes a 60 degree with the horizontal there. And each one obviously is 60 degrees. Now that's the first angle that we have to try and replicate, and it's very important that both working faces are at the same angle. So even if it's not quite 60 degrees, they have to be the same, otherwise your drill's going to behave badly. It's going to wander around the work and not make a very nice round hole. Now the cutting edge needs to be nice and straight, no chips in it or anything like that, and it must make a sharp angle between the working face and the flute of the drill there. If this edge is rounded in any way or burnished, then it definitely needs sharpening or touching up. Now what happens when the drill is spinning in a clockwise direction? The cutting edge digs into the metal, and you take a shaving off with each revolution. So it's very important that the cutting edge is higher than the trailing edge, because what happens is the cutting edge grabs first and cuts a shaving off, and then the trailing edge stops it from going any deeper. Now that angle between the cutting edge and the trailing edge is normally about 7 to 10 degrees. Now the 7 or 10 degree angle between the cutting edge and the trailing edge is called the relief angle. You don't want to go too high with that angle because that's what limits the thickness of the cut. If you try and cut too much metal in one revolution, your drill can jam or stutter and jump around, and it doesn't work very well. If you keep your angle below 10 degrees, between 7 and 10 degrees, then you're going to get a nice smooth shaving, and I like to see a little spiral of metal coming off the work face. But if it just forms flakes, that's fine. Just to show you what I mean, if you just took the standy knife, you can see the cutting edge is quite obviously the one in the front there, and the trailing edge is the one at the back. So if I try and cut this piece of wood by lifting the cutting edge and just the trailing edge is touching, that's what's going to happen, nothing at all. But then if I tip it slightly the other way, there we go, we're getting a shaving of coming off. And the more I tip it, in other words, the bigger the relief angle, the deeper the cut and the more I'm going to take off. Now if you stay tuned to the end of this video, I'm going to be discussing a few troubleshooting tips. So if your drill bit's not performing properly and you want to know why, just stay tuned to the end of the video. Now before we do any sharpening, I just want to give you a few tips about setting up your grindstone before you start sharpening. Now if your grindstone looks something like this, you're wasting your time. This is a very coarse grindstone and it's been abused, and the front edge is rounded. And the other thing that's wrong here is you can see there's quite a wide gap here between the wheel and the stage of the grindstone. Now that's quite dangerous because if you get anything sucked in there, a drill bit or your finger for instance, it's going to turn out badly. Now when you're grinding anything, it's important to be above the center of the wheel, because above the center of the wheel's going to push you away. So if you have a problem, you just move away. If you're below, it's going to suck you in and you'll go into that gap there, and that's quite dangerous. And always wear eye protection, because bits of the wheel can come flying off and bits of metal can come flying off. So very, very dangerous. I don't normally wear gloves because I just feel it's safer. I've got more control if I'm not wearing gloves. Now that wheel, as I said, is hopeless, so don't even bother trying to sharpen there. You'll never get consistent results. This is what a wheel should look like if you're going to sharpen. This is a very fine white stone. Now you'll notice this one, there's very, very little gap, less than a millimetre gap between the wheel and the stage, and the front of the wheel is perfectly flat. Now if your grinding wheel's not perfectly flat along the working face, then you need to dress it. Now to dress it, you need a diamond dressing point. This is the one that I use. It's got a single diamond in the middle there. And you just set it up like that. With the wheel spinning, you just move across the wheel like that, taking off any high spots. And the way to check it is to just check that the gap between the wheel and the stage of the grindstone are uniform all the way across. Right, now that you've got that bit of knowledge, we can go ahead and do some sharpening. And what I've done here is drawn some lines off the stone at about 60 degrees. I just cut myself a bit of plastic, put it against the wheel, and then draw those lines. Now, I've marked on this wheel a horizontal line because it's important when you're sharpening to keep your cutting edge horizontal. Any angle on the cutting edge and the wheel is going to give you a bad result. And I just put this arrow here to show you the direction that the wheel is traveling. So let's do some sharpening. Now when you look at a drill pointing the point angle away from you like that, the cutting edge is always on the left. So when you're setting up your grindstone, you'll always come from the left like that and put your cutting edge against the wheel. Now when I'm aligning my drill for sharpening, I go through a few steps. The first step is to get the cutting edge horizontal. Then I bring it up to the wheel, touch the wheel. Now it's got to be touching the wheel along its full length of the cutting edge. and then I check to see if I'm parallel to my 60-degree lines. If I am, then that's fine. If I end up like this, then I know my point angle needs to be adjusted first to bring it so that the shaft of the drill is parallel to my 60-degree lines. So by doing that, I'm establishing my point angle is correct, or if I need to adjust it. Then once I've established my point angle, I lift the tip of the drill about 7 to 10 degrees off the grinding stage, and that sets my relief angle. And then I sweep up, keeping my relief angle constant, and as I move up, I rotate the drill like that so that I'm trimming the working face and maintaining my 7 to 10 degree relief angle. So this is the action. Up, come vertically up the stone and twist. Vertically up the stone and twist. Don't go off to the side or change any angles. Try and keep everything the same. And then when you've done that, you flip it over and you do the other side exactly the same, trying to keep everything constant so that the two sides are mirror images of each other. The other thing that's important when you're sharpening drill bits is not to overheat them. So don't press very hard on the stone and don't keep it there for a long time, and have a little tub of water next to you so that you can keep dipping your drill in the water and keeping it cool. Very important that, because these drills are made of hardened steel, and if you overheat them, you lose the hardening and then they get blunt very quickly. So I'm going to start by sharpening a 4mm drill. Now with this one, I'm just going to get my cutting edge horizontal like that, get a 10-degree slope off the stage, and I just press it on like that gently until it's sharp. Thin drills, I just press it against the wheel while it's running, and that's all you need. But with thick drills, it's a little bit more tricky. Because with a small drill, there's not a lot of working face. So you just press it against there and you're fine. But if you're using a big drill like this and you just press it against there, because of the curve of the drill, you're going to get a concave surface there. And ideally, you want a slight convex on that surface. So let's do that. Now it's not a bad thing to just keep it in that place and flip it over to the other side, get it horizontal and touch again. And there we go, that's all there is to it. Now what I very often do, if I just want to check that I've got it right, I put my finger there and I just twist the drill on the finger, and I can feel the cutting edge scraping against my skin. And that gives me the feeling that if I haven't got the cutting edge ahead of the trailing edge, then when I do that, it's quite smooth. It doesn't dig into me at all. So I know it's not going to work when you put it on metal. Because now I'm going to show you my technique for sharpening a slightly wider bore twist drill. Remember to cool it, then flip it over, do the other side. And then always good to just check your work, make sure your two faces are the same, they mirror images of each other, and make sure that your center point is in the center of the drill, or in the long axis of the drill. Otherwise your drill's going to wander. Another way of checking it is just use a little wax block. You dig it in and then start twisting, and you can see the shaving coming off the cutting edge like that. So that tells you you've got it correct, but you must be coming off the wax at 90 degrees because that's how you'll be drilling. You can check the other side is also cutting, so that's very important to balance the two sides, otherwise your drill doesn't behave very well, and your hole becomes elliptical rather than perfect circle. Now, just a quick way to check your point angle is to get two hex nuts like that, put them together, and then bring your drill bit up like that, and if it fits snugly in that gap there, then you're fine. Right, let's see how these drills that I've just sharpened perform in practice. Now, it's always good practice to use a center punch. Keeps your drill central and stops it from wandering. And I'm also very fond of using a drop of lubrication. It helps to keep the drill cool and helps it to cut smoothly through the metal. That was pretty easy, and if you look at the hole, it's perfectly round. And as I said to you, I love it when it comes off in little spirals like that. That means I've done a good job with the sharpening. And it's important when you start drilling to start with quite heavy pressure, because you're trying to get your chisel edge to penetrate the metal so that your cutting edge can engage with the metal. And as the cutting end starts engaging, you'll see these flakes starting to appear. So then you can slack off a bit and then just drill so that the drill's going smoothly through. If the drill starts shuddering, that means you're pressing too hard. And you might find when you get to the other end, when it starts to come out the other end of the metal, it wants to bite into the metal. So a good idea to slack right off, very light pressure as you come through the other side. Right, it's also good practice if you're drilling with a wide drill, say 8 millimeters plus, to use a pilot hole. That allows your chisel edge to penetrate the metal, and that engages your cutting edge so it can cut straight away. And it's especially important to have a pilot hole if you're drilling through thick metal like 3 to 5 millimeter stuff. And it's also very important to use lubrication continuously while you're drilling through metal like that to stop your drill from overheating. And if your drill gets hot or you see smoke coming out, just stop, let it cool down, and then carry on, because once your drill gets blunt, you can forget it, it's not going to penetrate. I'm going to use the previous hole that I drilled. That's about a 4 millimeter hole, and I'm using about a 10 millimeter drill at the moment. Normally your pilot hole has to be a little bit more than the length of your chisel edge. I normally drill my pilot hole about 1/3 of the diameter of my final hole, and that usually works for me. Right, so let's try this one. Put a drop of lubricant there. I quite like running it down the drill a bit like that, because that puts it in the right spot on your work surface, but it also adds a little bit to the drill surface as well. So let's try this one. There we go, a nice neat round hole and minimal effort going through the metal like a knife through butter. There was a little bit of smoking and a bit of shuddering there, but that's because I was pressing a bit hard. Now, I said I'd talk a little bit about troubleshooting if your drill's not performing well, to try and find out why it's not performing well so that you know what to do to correct it. Now, the first thing is, if the drill won't penetrate the material and won't cut nicely and usually gets a bit hot, that's usually because either your cutting edge is blunt, and if you look on the edge there, you'll see it's a little bit rounded and burnished, and so that means you need to dress that cutting edge and get it sharp again. The other reason that could be happening is if your relief angle between your cutting edge and your trailing edge is in a negative form. In other words, your trailing edge is touching the material before your cutting edge. That means it's not going to penetrate and the drill's going to get hot. So then what you need to do is sharpen again, but making sure that your cutting edge is higher than your trailing edge by about 7 to 10 degrees. Now if your drill's not staying central and it's wandering around, either you need to use a center punch, which I recommend, and that will help, or a pilot hole if it's a wide bore drill. But sometimes if your chisel edge, this one here, this little blue one here, is coming off at an angle, in other words, you've sharpened past the midpoint on one of them, and the other one you've maybe got to the midpoint, check your chisel edge. It should be running more or less 90 degrees like that to the work face. So check it's running like that and not running at an angle like that. Otherwise your drill will wander around a bit. But usually a center punch or a pilot hole will help. Now another thing that can happen is that your drill shudders quite a bit and it oscillates, moves from side to side a little bit. And when you finish drilling, your hole is not perfectly round, it's elliptical or somehow out of shape. That usually means your two working faces are not identical, and that's what's causing it to move around like that. So you need to check that both these faces are exactly a mirror image of the other, and if not, then you've got to correct that with the grindstone. Now another thing that can happen is when you're drilling, the drill stutters a bit and gets a bit hot straight away, and that's usually because either you're putting too much pressure on the drill or your relief angle is too steep. So each revolution you're taking too big a cut out of the metal, and that's causing, it can even cause the drill to stall sometimes because it just can't take the load. So check your angle between your cutting edge and your trailing edge. Remember I showed you that you can do it on wax just to see how much it's picking up. If it's picking up too much, then you need to flatten that angle a bit, but always making sure that your cutting edge engages first and your trailing edge at the back. Now if you found this useful, please like and share this video and subscribe to this channel if you haven't already done so. And if you have any comments or questions, we'd love to hear from you. Just scroll right down to the bottom, you'll find the comment section there. Thank you very much for watching.